Okay, so as I mentioned earlier, the this lesson is not nearly as difficult as the one we did on Monday. Mondays, like I said, was probably the most difficult lesson out of all of them just because of the proofs. This goes back to a lot more calculation stuff. And most of this, really honestly, is just getting back to the using the unit circle and knowing where you're looking for information. So it won't be too bad. The first thing I will suggest, though, is if you printed out a unit circle, the one thing I would write on it is in that fourth quadrant, I'd write the negative angles. So it's negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Because when we're looking at our functions, our inverse functions, sine and tangent are both going to be working from negative pi over 2 to positive pi over 2. And cosine works from 0 to pi. So we're going to use the first quadrant and the fourth quadrant, but the fourth quadrant is going to be the negative values. That's because when I'm looking at a function, it has to be a one-to-one relationship, or it has to actually be one input for every output. And the sine function repeats itself in the first and the second quadrant. So I can't use those two quadrants. However, it does not repeat itself if I go to the negative first quadrant and the first quadrant. And we have one full rotation of all the values. So that's why we look at those quadrants for it. So using those, we're going to come back and use the unit circle quite a bit. So, all right. The next thing you want to write down is these three, the domains. So the domain of the sine, inverse sine is negative pi over 2 to pi over 2. The inverse of cosine is 0 to pi, and the inverse of tangent is negative pi over 2 to pi over 2. So basically, I just said making sure you have those written down, because when everyone we're going to look at, they have to fit into those quadrants. And some of these problems, when we're doing them, it falls into the situation where it looks like it's really simple, and you get the answer wrong because you're pulling something from a different quadrant. So it's got to be between those two quadrants. So the first question says find the exact value of sine negative 1, the inverse sine of negative 1/2. So we're going to go back to our unit circle, and we're going to look for negative 1/2. So remember, the sines are your y values. So negative 1/2 falls right down here. That's the negative 1/2. So that means it's the negative pi over 6 is going to be my value that's going to give me that. So when we go back and look at my problem, the value that's going to give me negative pi over 2 is negative pi over 6. Great. Okay, let me open back up the assignment now. Apparently, I waited too long to do the problems. All right, so this one is negative square root of 2 over 2. So again, I go back to my unit circle. And negative square root of 2 over 2 is right down here. So the answer is going to be negative pi over 4. Simple enough. So it's whatever it is. It doesn't necessarily have to be sine. The two that, like this one's tangent of negative 1. So we're looking for the inverse tangent of -1. So now on my tangents, when I'm looking at my unit circle, the
Hey,
-1.
Professor Baker,
Yep.
there's a couple of us that can't see your screen.
Okay. I will reshare it. I hate when that happens. All right, so let's reshare. I don't know why it does that because it should just stay shared, but for some reason there's a glitch. Can you see it now?
Yes, great.
Awesome.
Gracias.
All right, no problem. So again, we're looking at the unit circle. So we've got our values, and we got the negative values in the fourth quadrant. So this problem that I'm looking at right now is inverse tangent of -1. So the tangent ones is y over x. So the only ones that are going to give me -1 are when the values are the exact same, the y and the x, and one of them is negative. So that's going to be down here at the 7 pi over 4 or the negative pi over 4. So that's going to give me a negative of 1 in tangent. So we go back to the problem. And then my answer is negative pi over 4. And that's all we're going to do for that topic. All the rest of them actually go right along with this. They just get a little more complicated and a little more things built into them. But they're basically all the same type of problem as that one. So let's move on to the next one. So the next one says, I want to find the exact value of the inverse of cosine for cosine of 5 pi over 3. So when we're doing this one, we have to do it in 2 steps. We have to find the cosine of 5 pi over 3, and then we're going to do the inverse of it. You would think if you take the inverse of the exact same function, that they would just cancel each other out and we'd be left with where we started. That's true if that number that we're looking at is in the domain of my inverse. So cosine of 5 pi over 3 is not between 0 and pi. So I'm not going to get 5 pi over 3. I'm going to get the value that's going to give me the same answer as the 5 pi over 3. So if we go back to my unit circle, and we look at the 5 pi over 3, so 5 pi over 3 is over here, and cosine is 1/2. So I'm looking down there. That's the 5 pi over 3. So now I'm going to look in the first 2 quadrants for cosine of 1/2. So I'm looking for the x value that's going to give me 1/2. And that's right there. So the answer for this question is pi over 3 because cosine's looking at those first 2 quadrants. So I'd put 5 over 3. So when you're doing them, just make sure whatever your answer is, it's got to be within the domain of my inverse functions. Let's do one more of those. Sine of 5 pi over 4. Now, 5 pi over 4 is not between negative pi over 2 and pi over 2. So we go back to my unit circle. And we're looking for 5 pi over 4, which is over in the third quadrant. And the sine is the negative square root of 2 over 2. So now I'm going to look in the first and fourth quadrant to find negative square root of 2 over 2, which happens to be down in the fourth quadrant at 7 pi over 4, which will be the negative pi over 4 is my value that I'm going to use. So the answer is negative pi over 4. Does those make sense? Because if this makes sense, it builds on this. So I just want to make sure we understand this part fine. All right. Next one, same concept, except we're looking for, it's going to give me the inverse of cosine, and then we're looking for the tangent of it. So the first thing we're going to find is the inverse of the cosine, and then we're going to look for the tangent value of it. Now notice this one, they're giving me a value in there. They're saying 3/5. 3/5 is not on my unit circle. So because it's not on my unit circle, I need to do that x squared plus y squared equals r squared. So cosine, the inverse of cosine is 3/5. So that right there, cosine is x over r. So I've got 3 squared plus y squared equals 5 squared. So y squared equals 16. So y equals plus or minus 4. Now, if my cosine was, if the x was 3 and my cosine, that means I'm going to the in the first quadrant, because cosine is either got to be in the first quadrant or the second quadrant. So if x is 3, that means it's positive. So I'm in that first quadrant. So if I'm in my first quadrant, that means my y is also going to be positive. So now my tangent of my answer is y over x. So it's going to be 4/3 is my final answer. So when you're doing it, we basically have to use what they gave us to find our x and our x and our y's or r's, depending on which values they give us. Find the missing piece, and then we use that to figure out the other part. But you still have to look at your domain of the inverse functions to figure out which quadrants we're dealing with. And that's going to help you figure out if it's going to be a positive or a negative value. All right, let's try one more of these. So this one's tangent, the inverse tangent. So that means that's y over x. So I've got 5 squared plus 12 squared equals r squared. So 25, so that's 169 equals r squared. So 13 equals r. Now a radius can never be negative. So now tangent of 12/5, that's positive. So if we look at my unit circle, in the fourth quadrant down here, my tangents are negative. In the first quadrant, my tangents are positive. So since this is positive 12/5, I know I'm dealing with the first quadrant. So when we're doing this, I know my x is 5, my y is 12, and my r is 13. So in this case, cosine is x over r. So it's 5/13 is my answer. All right. Only difference of these ones, again, they just get a little more complicated, a little more involved in the functions. This one's dealing with cotangent instead of just tangent. But it's the same process that we're going to do. So I've got my x. So my x is -2, and my r is 3. Now remember that my r can never be negative. So that means if it was -2/3, my x has to be the negative value. And I'm looking for my y. So we do -2 squared plus y squared equals r squared, or 3 squared. So y equals plus or minus the square root of 5. Now we just have to decide if it's going to be positive or negative in this case. Now in this one, cosine is always in the first and the second quadrant. So my cosine y is always going to be positive. So in this case, my y is the square root of 5. Now cotangent is x over y. So in this case, cotangent is negative 2 over the square root of 5. All right, even though this one gives you a letter, the process again is exactly the same. We're not going to make any changes to it. We're just going to end up using a letter in it. So that means my calculations are going to be a little more complicated, or I'm going to have a variable in my calculations. So same thing. So tangent is u. So tangent is always the y over the x. So that means y is u. And x in this case is 1. I still need to find my r. So we've got 1 squared plus u squared equals r squared. So it's the square root of 1 plus u squared equals r. And r can never be negative. So I know that value there. So now my sine is y over r. So in this case, my sine is u divided by the square root of 1 plus u squared. And this one, the quadrant doesn't matter because it's a u, it's a variable, so it could be in either the first or the fourth quadrant. Same thing. So I've got my x, y, and r. The y is v, and the x is the square root of 9 minus v squared. And we need to figure out my r. So I've got the square root of 9 minus v squared plus v squared equals r squared. So it's 9 minus v squared plus v squared. So 9 equals r squared. So r is 3. So the process stays the same. They just get a little more complicated as you go through and do them. Cosine is x over r. So in this case, my cosine is the square root of 9 minus v squared divided by 3. All right. Any questions on those before I go on to the next set of problems?
Can you just briefly explain why we're looking at the unit circle again? Because that's the only part throwing me off.
So some of them I have to, like the first few of them, we had to use the unit circle because it wanted the exact value and it was giving me values that were on the unit circle. Technically, you didn't have to. You could have done it the exact same way I was doing with the X, Y, and the R. It just makes it a little more complicated and more process to do it. When the unit circle basically just looks at it and you get the answer. So I think like 1, 2, and 3. Yeah, 1, 2. Actually, just 1 and 2, you really need the unit circle for, because it just makes it simpler to do. 3, 4, 5, and 6, you're using the Pythagorean theorem form.
Okay. And then I do have a question on 6.
Yep.
In that answer, Why can't you put like why can you simplify that like at all or no?
No,
Like
because you
if
can't do the square root of 9 minus v squared.
wait, say
Like you can't do the square root of 9 minus v squared.
yeah, that's true. Okay. All right, never mind. Thanks.
That I'll actually just show it to you because there's a lot of people who think you probably can, and I know why you said it. So remember, 9 minus v squared, just so nobody makes this little mistake, is 3 minus v, 3 plus v, not 3 minus v squared, which
Yep.
is a lot of people think. So when you're doing addition and subtraction, you have to factor before you can take the square root of it. If it was a perfect square, you could have. So like if it was 9 minus 6v plus v squared, you could have, because you have that. It's 3 minus v each time. But since it's not a perfect square, we can't do it that way.
Okay. Thank you.
No problem. Good question. All right. So the next, this topic, actually, most people, I think, already have done. All you're doing is putting it in the calculator. So use the Alex calculator. It's going to be a lot easier than using your cell phone or anything else. It's the -1 buttons up top. Make sure you give the answers in the option they said. They want the answers in radians. So make sure your calculator is in radians. So we do cosine -2.31. And you'll notice it comes up as undefined. Cosine's got to be between the 0 and pi. And -2.31 is not between 0 and pi. So the first one is undefined. We do sine of 0.73. And they want us to run in the nearest hundred, so 0.82. And then we do tangent of -153. And you get -0.99. So just use the Alex calculator, quick, easy. Just type them problems in. All right, so next one we have to do is now we're going to actually start looking at solving equations. And again, this is where those unit circles are going to come into play for a lot of these. Because we're looking for exact values of them. So we have, in this case, 2 cosine theta minus 1 equals 0. So we're going to solve it just like we would solve any normal equation if it was an x. So cosine theta equals 1/2. So now I can look at my unit circle, that wonderful unit circle that we all love. And we're looking for cosine of 1/2. Again, remember, we're looking at cosine between 0 and pi. So cosine of 1/2 is 5 pi over 6. Actually, I take that back in this problem because I think they're looking at, yeah, they want to know all the answers from 0 to 2 pi. So we're looking for all the answers that are going to give me 1/2 from 0 to 2 pi for cosine. So cosine is my x value. So we're looking at that one and that one. So my answer is pi over 3 and 5 pi over 3. There's the two answers that I'm going to type in. So pi over 3 and 5 pi over 3. And we type in both those answers. So if there's multiple answers, type them both in. And actually, when we get to some of the later ones, we're going to be setting the entire interval range. So you have every possible answer that it's going to occur in. Same thing, this one's secant. So secant theta plus square root of 2 equals 0. So secant theta equals negative square root of 2. Now remember, secant theta is cosine, the inverse of cosine. So cosine of theta is negative 1 over the square root of 2, or negative the square root of 2 over 2. So we're looking for the x values that are going to give me negative square root of 2 over 2 on my unit circle. Because they want the exact answers in terms of radians, in terms of pi, you cannot use a calculator to get these answers. That's why they're going to come out to be 1. So if you get something at the end that is not on the unit circle for these problems, you probably made a mistake. So if I go back to my unit circle, so we're looking for cosine of negative pi over 2. So cosine of negative pi over 2 is going to be 3 pi over 4 and 5 pi over 4. If you have done your unit circle and done all your calculations for your other ones, you wouldn't have to change it over to cosine to find it on the unit circle. You could have just done it from the secant. I didn't do that, and I don't think most people do, so that's why I switched it back to the sine, cosines, and tangents. All right, before I go on to this one, any questions on 8 or 9? For pi over, which one was pi over 3? So this one. So when we were looking at it, we got cosine of 1/2. So cosine of 1/2, put that there. Because I solved the equation. So I'm looking at my unit circle, and I'm looking for cosine of 1/2, which is the x value. So 1/2 was right there at pi over 3. And the 5 pi over 3. So we're looking for the answer, and then we're trying to figure out which thetas are going to give me that answer, basically. So which thetas or which angles are going to give me 1/2 as the answer. Does that answer your question, Caleb? Okay. I realized why I wasn't seeing chat, because it was off the side of my screen. I was trying to figure out why you guys were quiet. All right, so the only difference in this topic compared to 8 and 9 is how they want you to write your answer. So if you look at 8 and 9, they tell me they want the interval between 0 and 2 pi. And this topic, they don't. They want all the answers. So when we're typing it in, we're actually going to click the problem that's going to give me the plus k pi for all k integers of k. So basically, what this is little functions going to allow me to do is say my answer was pi over 2. Let's say my answer was pi over 2, but I also had 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth. So every one of those answers would work. So when I would write this answer in there, I would write it as pi over 2, and then plus it's 1 pi between each of these. So I would do plus k times pi, because it's basically going to give me every pi, so 1 pi, then 2 pi, then 3 pi, then 4 pi, variation of that. Because if I added 1 pi to that, I'd get 3 pi over 2. If I added 2 pi to that, I'd get 5 pi over 2. 3 pi, I would get 6 pi over 2. So that basically says the list of values. So you can't write them all out. By putting the plus that part in there, you're going to get every single value that you want. Let's say I wanted 3 pi over 4, and then it was 11 pi over 4, and it was 19 pi over 4. So now these are going by 2 pi. So the only change I would make to my problem is when I typed it in, I would do the 3 pi over 4, which is my first value. And then I do that, I forgot the plus 2 of that. So it'd be 2 times the values. So it'd give me 2 pi, 4 pi, 6 pi, 8 pi, so on and so forth. So you have to write the first few values out and then figure out what the variance between those is. So this way you get every single value in one equation. All right, now let's do this problem. So we've got 2 cosine theta minus square root of 3 equals 0. So I've got cosine theta is square root of 3 over 2. So if we look at my, again, going back to the unit circle, and I'm looking for square root of 3 over 2. So square root of 3 over 2 is right here at the pi over 6. And square root of 3 over 2 is at the 11 pi over 6. So those are the two values that are going to give me square root of 3 over 2. So I've got pi over 6 and then 11 pi over 6. So now, there's no easy way to get from pi over 6 to 11 pi over 6. So my two answers, when I'm doing it, would be pi over 6, 11 pi over 6, and then 13 pi over 6, and then 23 pi over 6. So from here to here, that's 2 pi. From here to here is also 2 pi. But there's no easy way to jump just one at a time. So in this case, I'm actually going to write both of them. So I'm going to write pi over 6 plus 2k pi, or 11 pi over 6 plus 2k pi. So you can write multiple answers in this. They've just got to show you going on forward after that point. So when I write this in there, I'm going to do pi over 6 plus 2, that, and then or the same thing, 11 pi over 6 plus 2, and then hit that button. Does that make sense?
I need to see it play out one more time. Can you do one more?
Yeah, I was probably going to, but
Right.
just wanted to sure if there was any specific questions on it. We still got a few more. Well, basically all the rest of these topics are very similar to this one. I want one that's not cosine. Every question seems to have been cosine lately. There we go. So this one, we've got 2 sin theta plus square root of 2 equals 0. So that means sin theta equals negative square root of 2 over 2. So I'm going to go back and look at my unit circle. And we're looking for negative square root of 2 over 2. And we're looking at that in the y values, because that's sine. So that's right there. That's 3 pi over 4. Oh, that's x.
Yeah. Oop.
That's x. That's the y one. And that's the y one. So we got 5 pi over 4 and 7 pi over 4 are the two values I'm going to look for. So 5 pi over 4 and 7 pi over 4. So the easiest way to write the final answer in this problem is if they give you multiple ones like that, you actually could just always do the or. And on a lot of cases, it's actually the only way you can do it. The only time you're ever going to be able to just do pi is if it was like in quadrant 1 and 3 or 2 and 4, if they were diagonally from each other. But if they're in quadrants right next to each other, you are not going to be able to put them together. So you'd have to write them both. So in this case, I'm going to have to write them both. So it's 5 pi over 4 plus 2. And then or 7 pi over 4 and plus 2, and then hit that. All right, let's go on to a harder one. Secant minus 2. So secant theta equals 2. Secant is the inverse cosine, so this is cosine theta equals 1/2. So I'm looking at the x values for 1/2 on my unit circle. So go back to my unit circle. X values for 1/2. I got pi over 3 and 5 pi over 3. So pi over 3 and 5 pi over 3. So I do the same thing. Pi over 3 plus 2. And then or 5 pi over 3 plus 2, and then the k-dot. All right, so the next one we've got, again, same thing. They just get more complicated. So it's not plus 2, it's plus 2 pi. So when I was writing it, hold on, I'll go back to the other problem real quick. So the only thing that when you hit that the k pi k composed of the integers, that button doesn't have a 2 in front of it. So when I'm doing the plus 2, I'm putting plus 2 and then I'm putting that other thing after it. So it's actually plus 2 times k pi. It's not plus 2, it's plus 2 times k. But you don't have to write the whole k and pi and everything else. There's a button for that. So all you have to do is actually put the plus 2 in front of it and then hit the button. Because in essence, what that's giving you is the pi over 3. And then the next one's going to be 7 pi over 3, 13 pi over 3, 19 pi over 3. Because in essence, I'm adding 2 pi to each one. And that's what that function's doing. And the other one is 5 pi over 3, 11 pi over 3, 17 pi over 3, and the same thing. So I'm doing plus 2 pi each time. So that function plus 2 times k, this is the original value. That's 2 times 1 pi. And that's 2 times 2 pi will give me the next value. That's what that function's doing. And it keeps going on till infinity with every integer. Yep, basically, you're just going to keep going around the circle. And that's why, so it's like, in essence, you could always do the ors. Sometimes it's just easier to write it without that if you can. But if you have multiple values, you can always put an or between it and write each one. And in some of these questions, you might have 4 values that work, and you could just do each one. The first one plus 2k pi, the second, then or the next one plus 2k pi, and have 3 or 4 equations there. That's possible. So. All right, let's solve a little more complicated. So we got 3 secant theta, or secant squared x minus 4 equals 0. So I've got secant squared x equals 4/3. So I'm going to do the square root of that. So secant of x equals 2 over the square root of 3. So now secant is cosine. So that's square root of 3 over 2. Now, when I took the square root, I did forget something. I forgot to put the plus or minus. So when you're doing the square root, you do have to put the plus or minus because all those answers possibly could work for this one. So when we're looking at my unit circle, I'm going to look at my unit circle for plus or minus the square root of 3 over 2 in the cosine. So let's go back to my unit circle. So cosine of 3 pi over square root of 3 over 2 is pi over 6. The negative is 5 pi over 6, 7 pi over 6, and 11 pi over 6. So I had put in all 4 of those answers into this problem. So pi over 6. And 11 pi over 6. And now this one wants my interval from 0 to 2 pi. So I'm only doing, and I didn't put them in order, but that's fine. Those values. So this isn't the k value where we're doing them all. This is just one revolution around the circle. This is the same thing, except this is the one with the k. So we're going to do multiple revolutions around the circle. So I've got 3 cotangent squared x minus 1 equals 0. So I've got cotangent squared x equals 1/3. So cotangent of x equals the 1 over the square root of 3, plus or minus. So tangent of x equals plus or minus the square root of 3. So we're looking for the values in tangent that are going to give me the square root, or plus or minus the square root of 3. So tangent of plus or minus the square root of 3. So let's go back to my wonderful unit circle. Now there is no one that's going to give, like on the unit circle, you're not going to see your tangent values, but remember, tangent is y over x. So if we look at, if it's 1/2 divided by the square root of 3 over 2, that's going to put my square root of 3 on the bottom, and I want my square root of 3 on the top. So it's going to be the square root of 3 over 2 divided by 1/2, and that's the square root of 3. So we're looking at that point. So it's the pi over 3, the 2 pi over 3, 4 pi over 3, and the 5 pi over 3 are going to be my 4 answers that I'm going to have for this one. And that's going to give me my plus or minus the square root of 3. So pi over 3, 2 pi over 3, and 5 pi over 3. Now, this one, they want us to write the plus or minus, or the plus k. So when I'm doing this, remember I said the diagonal ones I can put together with just pi. So if I'm looking at pi over 3, or the pi over 3 to 4 pi over 3, that's just adding a pi. So I can write this as plus k pi, because that's going to give me the pi over 3 and the 4 pi over 3. And then I can do the 2 pi over 3 plus k pi, because that's going to give me the 2 pi over 3 and then the 5 pi over 3. So I don't have to write this 4 times with the plus 2. I can write it twice and just do the k, because they're the 4 diagonals. So it just, but if you wanted to, you could write all 4 with the 2 pi, and it'll accept both answers. Two more. All right. So we've got tangent of 3x plus square root of 3 equals 0. So tangent of 3x equals the negative square root of 3. So the first thing I have to do for this is I'm going to find, let's just do the tangent of m equals the negative square root of 3. Let's find that answer. So which values of tangent are going to give me negative square root of 3? So the first thing in my unit circle, so that's going to give me the ones that are opposite, and the square root of 3 is on the top. So that means the square root of 3 was in the y, and they have to be opposite of each other. So that means I've got 2 pi over 3 and 5 pi over 3 are the two values that are going to give me negative square root of 3. Now, we're not done with this problem, because in this problem, m is that. But I wanted 3x. So I have to take 3x equals 2 pi over 3. So that means x is going to equal 2 pi over 9. And then I got 3x equals 5 pi over 3, which means x also equals 5 pi over 9. So once you find your values, you then have to deal with whatever's inside of the function. So in this case, it was a 3x, so I have to divide both those answers by 3. Now in this one, I'm just going to write them as the plus or minus, or the plus 2 pi. So I've got 2 pi divided by 9 plus 2 pi, or 5 pi divided by 9 plus 2k. Why did I get it wrong? What did I miss? Oh, seriously. That's not what I wanted to do. Oh. I forgot to divide the 2 pi that by that one too. All right, let's just do another one of these. I missed dividing the 2 by. I'm going to wait till Caleb finishes typing. Oh yeah, I'm going to go over this one, and 15 is the same thing. And plus, I got it wrong, so I kind of have to go over it again. Otherwise, I'm not going to get the right answer. All right. So if we're looking at sine of 2x equals 1, instead of looking at the 2x, I'm going to look at m equals -1. So I want to look at my unit circle in this case, and I want to find all the values of sine that are going to give me -1. So in this case, the only value of sine that's going to give me -1, so m equals 3 pi over 2, because that's going to give me my -1 for my sine value. That part make sense? That's kind of what we were doing before. All right. So then on the next piece is, since I'm not looking for m, I'm looking for x. So I've got the 2x equals 3 pi over 2 plus 2k pi. So that's what my 2x equals, is this whole thing right here. So I'm going to divide everything by 2. So x equals 3 pi over 4 plus, in this case, k pi. So the piece that I missed in the last one was dividing that part by the actual inside number. And that's what happens when you rush. So 3 pi over 2 plus, and then the k. If you needed to divide it by something or anything else in there, you could also do the division piece in there too. So I could go back in here, like say if I wanted to divide that by 3, I could put divide by 3 in there if I needed to. Oh, it's 3 pi over 4. Much better. All right, let's do one more of those. Actually, let me see 15, because I think 15 is the same. Nope, let's do one more of those. 15 is different. So I've got square root of 3 tangent of 2x minus 1 equals 0. So I've got tangent of 2x equals 1 over the square root of 3. So now in this problem, I'm looking for the values that are going to give me 1 over the square root of 3. So this time the square root of 3 is on the bottom.
I don't even see Baker in the people in this meeting. I think something happened with his computer.
You think he disconnected or something?
Yeah, he's not in the participants anymore.
Interesting.
Well, I think that just about does it for class.
I mean, it's about that time.
It is.
Hey everyone, I have a question. Was this still less section 1 or was it 2?
Oh, that's a great question. I believe that is the first question that we had is a question that I was stuck on for the homework. So I still think that's in section 1.
Okay.
I also did just want to throw out there for anyone that
Hello.
oh, that's a familiar voice.
All right. So yeah, my Wi-Fi my internet went down in the house, so I'm literally connected through my hotspot on my phone right now. So, give me 1 second. I'm almost done. So, gotta love technology. All right. Is it actually still recording? That's the other question. Oh, good. It's actually still recording. Let's just hope it actually stayed recording.
Yes.
Yes.
Okay. All right. Awesome. Because I'm on one computer instead of 2 right now. All right. So we've got tangent of 2x equals 1 over the square root of 3. So we've got to look at my unit circle and find which values of the square root of 3 is going to give me my tangent values. So that's going to be with the square root of 3 on the bottom. So that's the pi over 6 and 11 pi over 6. And we're looking for positive, oh, sorry, not that one. Looking for the positive one. So actually it's going to be 4 pi over 3. Nope. 7 pi over 6. So those two are going to give me the positive values of tangent. So go back to my problem. All right, so I've got pi over 6, and then it's going to be plus. So now in this case, what I really want to do, so this is actually exactly plus pi because they're diagonally from each other. So my value of 2x equals pi over 6 plus k pi. So now I'm going to divide the whole problem by 2. So x equals pi over 12 plus k over 2 pi. So when I type it in, pi over 12 plus, we hit the button, and then we're going to have to go back and divide by 2. All right. Does that make sense? Or kind of make sense?
Could we do one more?
Yeah, sure. All right. So I've got cosine of 4x plus 1 equals 0. So it's cosine of 4x equals negative 1. So I'm looking for the values of cosine that are going to give me negative 1. Let's go back to my unit circle. Now remember, cosine is my x value. So the value that's going to give me negative 1 is pi. So I have 4x equals pi plus k pi. And then we divide the whole thing, plus 2k pi. Divide the whole thing by 4. So x equals pi over 4 plus k over 2 pi. All right, we've got one more problem. And by the way, I can no longer see chat. So if you're texting something in chat, I cannot see it. So if you need something, just speak up. All right, last one. This is the same thing, except this is just between 0 and 2 pi. So I don't have to worry about doing the plus or minus, the plus k pi thing. So it's tangent of 2x equals negative square root of 3. So I've got 2x is going to have to equal the values that are going to give me the negative square root of 3. So this one's in the y value. And they have to be different. So I've got two pi over 3 and the negative one. And 5 pi over 3 are going to be my two answers there. But now I've got to divide them both by 2. So x is 2 pi over 6 or pi over 3 and 5 pi over 6. Now, they want all the answers between 0 and 2 pi. If I put those two answers in, I'm going to get the answer wrong. Because so I had 2 pi over 3 and 5 pi over 3. So the next value that I would have had if I kept going around the circle is 8 pi over 3 and 11 pi over 3. If I was to divide those by 2, I get 8 pi over 6 and 11 pi over 6. Those two values are also between 0 and 2 pi. So because I'm dividing by 2, I have to go around the circle twice to get all the values that were going to work. If I was dividing by 3, I'd have to go around the circle 3 times to get all the values that would work. Don't worry, I'll do another one of these. And if I remember right, you do not have to simplify, so I'm not going to worry about it. Correct. All right. So this one, tangent of 2x over 3 equals the square root of 3. So this is the positive version of square root of 3. So I'm going to look at my unit circle. And I want to find the positive value of square root of 3. So that's going to be 2x over 3 equals pi over 3. And the other positive version of it is 4 pi over 3. Now, I have 2x over 3. It's less than 1, so I'm not going to go around the circle multiple times. So I'm just going to go around the circle the one time. And I'm going to multiply basically both sides, the whole problem, by 3 over 2. So this becomes 3 pi over 6 and 12 pi over 6. So they want all the answers from 0 to 2 pi, but not including 2 pi. So the answer is going to be 0 and 3 pi over 6. Oh, they didn't want 0. They should have wanted 0. Should have worked. All right, then it's just the 3 pi over 6. I figured they want that one reduced, but they don't. So it's just going to be, so that, since that is exactly 2 pi, they didn't want it. One more of those? Am I
Yes,
still
please.
online? Okay. I just want to make sure I'm still actually connected because the cell signal is not great in my house. All right, let's do one more. All right, so this one is cotangent of 2x over 3 minus 1 equals 0. So we're looking for the cotangent of 2x over 3 equals 1. So in essence, I'm looking for tangent of 2x over 3 equals 1. So we're looking at the values where they're both the same and it's positive. So I have pi over 4 and 5 pi over 4. And then we're going to multiply those by, so 2x over 3 equals pi over 4 and that. So we're going to multiply the whole problem by 3 over 2. So x equals 3 pi over 8 and 15 pi over 8. Now in this case, the 15 pi over 8 is less than 2, so we're going to have both answers. All right.
Professor,
Yes.
don't we need a 2K pi?
Not in this topic.
All right.
So in 14, you needed the 2K pi, and this one you don't. Because this one, see how the problem's written as it's the interval between 0 and 2 pi. So they're just looking for those exact values. The other way to know you don't need it is they're not giving you the button and the tool. If they don't give you the button, it's not going to work. All right. Questions? So tonight's, so as I going back in the messages, this is actually the end of section 1 and the beginning of section 2. So you should actually be able to finish section 1 and start section 2 with what I covered tonight.
Thank you.
You're welcome.